Bismillahirrahmanirrahim. Our lesson today, inshallah, is determining the types of the roots of the quadrilateral equation in algebra. What is the meaning of the discriminant? Discriminant, if I have standard form of an equation of second degree quadratic equation, ax power 2 plus bx plus c equal 0. This is the standard form of quadratic equation. And one of the roots or the two roots equal x equal negative b positive or negative square root b power 2 minus 4ac over 2a. If a is the coefficient of x power 2 and b coefficient of x and c is the absolute term. The discriminant equal b power 2 minus 4ac. I will use it to determine the type of the roots. Type of the roots, the two roots means the two values of x. Again, discriminant equal b power 2 minus 4ac, where b is the coefficient of x and a coefficient of x power 2 and c is the absolute term. If the discriminant more than 0, then the two roots are real and different. I have three types of the two roots. The first one, if the discriminant more than 0, then the two roots are real and different. How? If I draw a curve of a quadratic equation, I will find the curve cut x-axis in 2 points. The 2 points here is real and different. Real and different. The first root equal negative half, and the second root equal 2.4. The two roots here are real and different if the discriminant more than 0. The second, if the discriminant equals 0, then the two roots are real and equal. This means if draw the curve, you will find this curve cut x-axis at 1 point. This point here is 0. Then the solution set of the quadratic equation drawn by this curve equal 0. Again, if the discriminant more than 0, the two roots will be two real and different root, and the curve cut x-axis at 2 points. If the discriminant equals 0, then the two roots are real and equal. If draw the curve, this curve will cut x-axis in 1 point. The third type, if the discriminant is less than 0, then the two roots are complex and non-real. Here, this curve doesn't cut x-axis at any point. This means the two roots are complex and non-real. Again, if the discriminant more than 0, you will get two roots, real and different, and the curve drawn by this quadratic cut x-axis at 2 points. 2 points. If the discriminant equals 0, then the curve will cut x-axis in 1 point, and the two roots will be two root real and equal, or 1 real. If the discriminant is less than 0, then the two roots are complex and the curve doesn't cut x-axis at any point. For example, determine the type of each of the following equation. The first quadratic 3x power 2 plus 10x equals 4. You should write it in the standard form. Then 3x power 2 plus 10x minus 4 equals 0. This is in the standard form, where a equals 3, b equals 10, and c equals negative 4. The discriminant equals b bar 2 minus 4ac. Substitution by b, a, and c. Then the discriminant equals 10 power 2 minus 4 times 3 times negative 4 equals 148. This number more than 0. Then the two roots will be two different and real root. Different and real root because the discriminant more than 0. Another one, x bar 2 minus 10x plus 25 equals 0. This quadratic in the standard form. A1, B negative 10, C 25. The discriminant B bar 2 minus 4AC by substitution, then the discriminant equal negative 10 all bar 2 minus 4 times 1 times 25 equal 0. Then the discriminant equals 0, I will get two real and equal root or one real root. Another example proves that the two roots of the equation 7x bar 2 minus 11x plus 5 equals 0 are two complex and non-real roots. Then find these two roots. At first, find the discriminant. Discriminant D equal B bar 2 minus 4 is C, where A 7, B negative 11, C equal 5. By substitution, then the discriminant equal negative 19. Negative 19 less than 0. Then the two roots of this equation are two complex and non-real. Complex and non-real. To find these roots, use general formula. Then x equal negative b positive or negative square root b power 2 minus 4ac is the discriminant over 2a. Negative b, I find discriminant. Negative b positive or negative root negative 19 over 2a. Then x equal complex and non-real root 11 plus or minus root 19i over 14. Another example, if the two roots of the equation x bar 2 minus kx plus 2k minus 4x plus 5 equals 0 are equal, then find the real values of k and find these two roots. The two roots here are equal, then the discriminant equal 0. The discriminant equal 0. How to find the discriminant? Discriminant b power 2 minus 4ac. B here is negative k plus negative k minus 4. Negative k minus 4. This is the b. And A equals 1 and C is the absolute term here 2k plus 5. I will substitution and find the discriminant. It will be k power 2 minus 4 equals 0. I will factorize, then x k minus 2 times k plus 2 equals 0. Difference between two squares. Then k equals 2 and k equals 1. 2 or negative 2, sorry. At k equals 2, I will substitute in the equation. Then x power 2 minus 6x plus 9 equals 0. This is the standard form of this equation. I will factorize. This is the perfect square. Then x equals 3. Again, you have here equation. And the two roots are equal. Find the real value of k and find these two roots. At first, write the equation in standard form. X bar 2, x and the absolute. Here, x bar 2 minus k plus 4 all times x plus 2k plus 5. Then a equals 1, b equal negative k negative 4, and c equal 2k plus 5. By substitution and discriminant b bar 2 minus 4 times ac, and the discriminant here equals 0 because the two roots are equal. Then k bar 2 minus 4 equal 0. Then factorize this or solve it by general formula, then k equals 2 or -2. At k equal 2, then the equation, it will be x power 2 minus 6x plus 9 equals 0. And find the value of x, then x equals 3. At k equal -2, I will substitution in this equation. I will get x power 2 minus 2x plus 1 equals 0, and x minus 1 all power 2 equals 0 by factorizing, then x equal 1. Then the two roots equals 1 and 3. 1 and 3, and the value of k, 2 or -2. Fourth one, if the two roots of the equation find, example 5, sorry, find the real value of m which satisfies that the equation x power 2 minus 2m minus 1 all times x plus m power 2 equals 0 has no real root. Has no real root means the discriminant less than 0. Discriminant less than 0. Discriminant b power 2 minus 4 ac less than 0. A equals 1, B equal -2m plus 1, and C equals m power 2. By substitution in the discriminant, then 2m minus 1 all power 2 minus 4 AC, this, it will be less than 0 because the two roots are not real and complex, less than 0. I will solve the inequality. 4m power 2 minus 4m plus 1 minus 4m power 2 less than 0. Then -4m plus 1 less than 0. Then 4m more than 0. Then m more than 1 over 4. Here, m more than 1 over 4. Then write this as interval. M belongs to open interval 1 over 4 and infinity. Example 6, find the real value of m which satisfies that the equation x power 2 plus 2 times m minus 1 times x plus m power 2 equals 0 has two real roots here may be different or equal. Then the discriminant, it will be more than or equal 0 because the two roots here, two real roots may be equal or different. Equal or different means the discriminant more than 0. By substitution, by a equal 1, b equal 2m minus 2, and c equal m power 2, then d equals 4 times m minus 1 all power 2 minus 4 m power 2 more than or equal 0. Then 4 distribute 4m power 2 minus 8m plus 4 minus 4m power 2 more than or equal 0. Cancel 4m power 2 with -4m power 2, then -8m plus 4 more than or equal 0. By subtract 4 from the two sides, then 8m less than or equal 4. Then m less than or equal half. Write it as interval. Then m belongs to -infinity and half. Example 7 proves that for all real value of a, there is no real roots. For the equation for x power 2 minus 12ax plus 9a power 2 plus 4 equals 0. To prove all real value of a, there is no real root. The discriminant not real. Here, the discriminant b power 2 minus 4ac A equals 4, B equals the coefficient of x, negative 12a, and the C is the absolute term, 9a power 2 plus 4. By substitute the discriminant here, then the discriminant, it will be negative 144 a power 2 minus 144 a power 2, negative 64, cancel. 144 was negative 144. Then the discriminant equal negative 64. The discriminant here less than 0 for all value of a. Then the two roots, it will be no real root, because the discriminant less than 0. Remark, if the coefficient of the quadratic equation ax power 2 plus bx plus c equals 0 are rational and discriminant is perfect square, then the roots are rational. Again, if the coefficient of quadratic ax power 2 means a, b, and c are rational, and the discriminant d is a perfect square, then the roots are rational number, real and irrational. The second remark, if the discriminant isn't positive, then the two roots are complex number and conjugate. Again, if the coefficient of quadratic a, b, and c are rational and the discriminant is perfect squares, then the two roots will be also rational. If the discriminant is not positive or negative, then the two roots are complex number and conjugate. For example, if a and b are rational numbers, a, b are rational, proves that the two roots of the equation are rational. You should prove a, b, and c are rational, and also the discriminant is perfect square. He give me a and b are rational, then c also rational, because multiplying two rational equals rational. A, b power 2 is a rational also. Here you should prove the discriminant is perfect square. The discriminant b power 2 minus 4ac equals a power 2 plus b power 2 all power 2 minus 4a times ab power 2. Then the discriminant here by distribution, it will be a power 4 minus 2a power 2 b power 2 plus b power 2. Here, this algebraic expression is a perfect square because the first is a square, the third term is a square, and the second term is the square root of first times the square root of third multiplied by 2. Then a power 2 minus b power 2 all power 2 is a perfect square. Then the discriminant perfect square and more than 0 also. Then the two roots are rational. Two roots are rational. Thank you.